Welcome everybody to the session. Today I'm going to talk about microservices. This will be mostly a theoretical session, and I'll talk about some of the core principles that are used while designing microservices. I will start with the evolution of applications. We will quickly take a look at how applications used to be built in 70s, then in 80s, 90s, and how it is built today. Then I will also talk about monolithic applications, what are the challenges and what exactly is monolithic. Then we will get into microservices, the standard principles that one has to follow. And if time permits, I will also show you a sample demo. Uh, uh, the application name is Piggy Metrics. It's a simple application that keeps track of your expenditure and your earnings, and it gives you a nice statistics about how much you save yearly or monthly. And finally, I have also put up some of the references that you guys can follow, and definitely those references will have more insight about microservices. If you read any articles or if you watch Hollywood movies, you will come to know that in early 70s, the applications that we built or the software engineers built were mostly DOS-based applications, or there used to be a terminal as the UI, and there used to be certain logic written in Pascal or even in shell scripts and a simple database like DB2. Most of those applications were also storing data in the files, and if your system fails in the middle of your operation, then you lose the data. There were no cloud-based or automatic backup. Everything used to be done manually. So reliability and scalability was the bigger issue, and also the user interface was not very friendly. Then in early 90s, there was a tool called Visual Basic, which was introduced by Microsoft, and still I'm not surprised if some people are using it. And if you have built any college level applications, you know that your user interface and the business logic is very tightly coupled. Everything is wrapped in a single application, and then your application talks to a remote database. You cannot scale it really. If you look at today's applications like a banking application such as HDFC or ICICI Bank, there are millions and billions of users of these applications, and you cannot expect the systems to go down. Towards the early 2000, there were things like HTML, JavaScript, CSS, using which we could build web applications. So we could host the UI in a server where it was more reliable. So we could access that from any system. But then the problem was, like, even the UI and the backend were very tightly coupled. Everything was needed to be deployed in the single server. So just imagine if you build an application, initially 1,000 people accessing it, but eventually the things becomes popular, and millions of users starts to access your system. Then you need to scale that application that you put in a single server to maybe multiple server. And in this case, since your UI and backend, everything is very tightly coupled, you had to scale the whole thing. You can't scale UI individually and backend individually. And this will be more clear as I proceed further. And then in 2010, we started looking into different architecture where we could separate out the backend logic from the UI. So what we could do is that we could have something like RESTful web services, and then we could have UI in JavaScript, and then we could access the backend using REST services. This was somewhat scalable because we could deploy our UI in a separate server and the backend in a separate server. Still, this was not the ultimate solution, and I'll tell you why. And because everything was in a single backend, then we thought, okay, maybe it would make sense to separate it into different services. And I'll give you an example. Let's say you are building a shopping cart or a shopping site. In a shopping site, you have to manage different services like product pricing, inventory, payment, order processing, and so on. Now, if you have everything in a single server, what would happen if your payment service has an issue? So if payment fails, everything will crash because you have put everything into a single server. And that's why you thought of separating into different services using a enterprise service bus. But still, this principle was not very clear. And we call this as a service-oriented architecture. Uh, Now, if you look at in 2021, something like Twitter, this is the official blog that they posted in 2013. I don't know how clear it is to you guys, but just try to look at the mess. Every tiny letter that you cannot read properly is a service. So just look at the number of service and the interlink relation between them that needs to work in harmony to provide you the service that Twitter provides you. So if you don't design your system and if you don't give enough thoughts to your application architecture, then you will be in a mess. And this is true because today anything you build, you need to be ready for millions and billions of users. And this is why we employ the concepts like microservices. And this started becoming popular from 2011 onwards. I would not say that today everybody uses it, but at least people are giving thoughts on it, and all big and large organizations, they have used it in all of their big projects. This is again a theory. This is my definition of microservices. So microservices is not a tool or technology, but it is a software architecture. So it's a design concept or software architectural approach where what you do is you divide your single applications into independent services, and you make sure that these independent services are independently deployable. Now I'll break it further. So previously I talked about the e-commerce applications where maybe you have different services like order processing, payment, shipping and all that. So what we are talking about here is that consider each of these services as your independent service, meaning if the payment fails, everything else should work. So if I go to Amazon.com and let's say their payment system is not working, still I should be able to see the product, I should be able to see the pricing of the product, I should be able to add it to the cart. And then when I go and try to process the payment, that time I will get an error saying that, hey, our gateway is down right now, but please continue shopping on our site or check after some time. And that's perfectly fine. So let's look at this a bit more in depth. So a monolithic architecture or an application which is developed using monolithic architecture, what we do is that typically we have one web UI and then this user interface, or what you call it as a website. So this website makes requests to the server. The server has a load balancer, something like Nginx or Apache Web Server. This also works as a reverse proxy. This forwards the request to something like your Tomcat or any application server, depending on the programming language that you are using. So in this case, I have given example of Java. So in Java, what you do, your entire application is built as a WAR, and you deploy it in a application server, something like Tomcat. And this guy makes request to the Tomcat. And then you have a single database. Now look at the issue that you may face. So this is fine for maybe 1,000 users or 10,000 users, but uh, think of it like, this is a watch store and you want to sell watches across the country or maybe across the globe, who knows? And in that case, such an architecture will fail. I'll give you the reason. Let's say the database fails. What would happen to your system? or there is some coding error in the shipping service and you deploy the war, what would happen? Your entire system will crash. Just for a simple error or simple mistake, you cannot affect your entire application. And this is the reason why what we say is that we want people to use microservices. And in microservices, what we basically do is that we deploy in these services independently. And what I mean by that is, I'll come to the pros and cons later. So what you can have is that each of these services you can deploy in independent servers. Okay, I can have some services written in Node.js, I can have something deployed in Netty, something in Tomcat, and I can have the UI in some other server. That's absolutely fine. Polyglot is perfectly fine over here. And each of these services also can have their independent databases. And my UI, and if I have mobile application, that's also fine, can invoke these services. Now the problem over here is that, you see, each of these service has to know, okay, so the UI has to know exactly in which server inventory service is deployed, exactly in which server the shipping service is deployed, exactly in which server the account service is deployed, and so on. But that's not practically feasible, because I should be able to dynamically stop a server if some and deploy the application in another servers. I should have a way to allocate the IPs dynamically. I can have multiple instances of the same server. If you know the concept of load balancing and all, to balance out the traffic, what you do is you keep multiple instances of the service. But the UI cannot be so smart. I cannot have all the endpoints, all the physical IP addresses configured in the UI. And at the same time, if I expose all of these services on the public IP, then there are concerns like security. Hackers can get into any of my server and then exploit it. So I need to take care of the security and other things. That also adds overburden. And so for that, to overcome such a limitation, what we do is that we use a specific software or another service which is called API gateway. Now this guy sits between the interface and the different services. So my UI has to know only one IP address or only one host name, and depending on whatever service I want, suppose let's say I have my URL, my site /orders/star, and then my API gateway will forward that request to order service. Similarly, if I want to check something related to shipping, my API gateway will forward the request to shipping service. So this guy, we make request to API gateway. API gateway will make request on our behalf to the REST services, and then it will get back to us. Now this, had a lot of advantages. Like, if you have, I don't know if you have built any applications on any public API, sometimes there are rate limiting. So, premium users can access the API, let's say 1,000 times in a minute, but free users would be able to make only 100 requests per hour, something like that, right? So those rate limiting concepts, if you want to implement, you do it here, API gateway level. And if you want to monitor, have logging, allow listing or block listing certain requests, you do all of that in the API gateway level. So, so microservices, again, is not a single principle. There are certain principles that you need to follow in order to achieve a microservice architecture system. So one of them is API gateway. So I told you what is the job of an API gateway. There are some of them which are industry standard, and many huge applications they are using them. And if you are in Java and if you know Spring ecosystem, then you can use Spring Cloud Gateway. Next concept in microservices is called service discovery. We deploy our services independently in different servers. Okay. One of the reasons for doing that is, let's say, my shipping service development team makes an update. Okay. So they can make deployment to shipping service only. I don't need to touch the other services that I have running. So similarly, if if for some reason inventory service goes down, still I have the other services running, so my applications is accessible. Now, also I told you that I can dynamically deploy in multiple instances, which means in multiple services. But the question is, if I have two instances of the inventory service, how would my API gateway know in which IP address my service is deployed, or which service to invoke? And for that, there is something called service discovery. Okay. So in service discovery, there is something called registry, or we call it as a service registry. So any service that is deployed, this guy, okay, this is like a phone call. This will make a phone call to service registry and inform that, hey, I am order service and I am hosted on 10.4.3.1 and on this port number. So any request comes for order, just forward it to me. I know how to process. Whenever the API gateway gets a API request from the UI, it talks to the registry. It says, hey, who is the order service, or what is the address of the order service? This guy returns the IP address, and then API request just makes a call to the order service. So, there is again a tool for that to implement, so which is called Netflix Eureka. This is the original project from Netflix, which they released under, and it is under the Spring Cloud umbrella. What we call it as the Netflix Eureka. Another important concept in microservices is circuit breaker pattern. So, like I said, there are independent services hosted on different servers. But let's say my order service is not working, and how would my payment or how would my API gateway know that this guy is not working? There is a problem in the order service. Server may get restarted, or if you are using things like Kubernetes or anything, then there has to be another instance that needs to start. So for that, the API gateway has to know. So what it does is that if you using circuit breaker pattern, it makes continuous health check. So it's like it keeps pinging this guy in an equal interval. So maybe in every 15 seconds or 20 seconds, whatever, based on your configuration. And then the moment it finds that, hey, its health is not fine, then it keeps a record of that. So whenever the UI makes a request about the order service, it returns an output based on the configuration. So, if you have configured to say there is some error, then it will reply there is some error. There is already a ready to use library which is called Resilience4j. Finally, the next concept that I will discuss is distributed tracing. So everything looks good theoretically, like deploy everything in independent host and talk to them. That's nice. But how do you trace errors, or how do you debug a problem? Let's say, you made a request, but the request took 2 minutes to process, which is not acceptable in today's world. And you want to trace down what went wrong and where the exact time was spent, whether API gateway took a lot of time or the payment processing service took a lot of time. So for that, you have something called distributed tracing mechanism. And there are, of course, ready to use libraries like Zipkin and Sleuth in Spring Cloud, which will give you a statistic, something like this, how much time was spent by in service 1, how much time service 2 took, how much time service 3 took, and so on. So you will get a detailed statistics of every request that happens and every error that occurs. This is a very nice example of microservices. The stack library stack is bit old because, as you can see, this is almost like 3 years old project somebody put up on GitHub. It's pretty popular. So, but this will give you a very good idea of microservices. So basically, there are three main services which would be running independently: statistics service, account service, notification service, and everything will be talking to each other via RESTful web services. And every service has their independent database, and there are endpoints for each of these services. And it explains, from the microservices perspective, what stack everything is using. The UI, then it makes request to the gateway. Over here it's Zool, which is the previous version of Spring Cloud Gateway. And then these are the services. Every service gets its configuration from the config service. So I know it's a bit too much for you guys, but just giving you a high level overview, so that when you get time, you can just clone this repository, see how things are implemented. And this one is pretty close to the industry standard. This is how we also build applications in the real world. So this is a good example for you if you are interested to build any project, any academic project and so on. You can see that the number of containers that I have running are almost like 9 or 10. You can see, account service, there is a different container. So every container is like isolated environment where everything is running. So account service has its own application server, and it's running in its own environment. Then the authentication service, then I have statistics. This is for monitoring purpose. Then I also have the gateway. Then I have something for monitoring as well. And this is the notification service. If I have my balance less, or if I'm spending too much, it would send me an email. This is the registry. If you remember, I talked about service discovery, where every service has to register. And this is the database for every service I have. Okay, service, I will answer your question. And database, I have one is for notification service, one is for statistics, one is for account service, and so on. So every service also has its independent databases. Your question is, what is the difference between Monolithic? And once you log in, you can put your incomes and expenses, and then it would give you your savings. And it tells me basically what is my expenditure per month, or how much money I am left out with, and how much rent I would spend per year, and so on. So I told you I can have a registry, something like this. So where every service will inform about its physical IP address and its port. And that's how the gateway will know which IP address to invoke. And that's exactly is happening here. This is my Spring Eureka. This is the registry server. And over here, every service is registering its name. So obviously, this is a dynamically generated ID. It is mentioning what service it is. So it is gateway and its port number on which it is hosted. Other one is how do you, let's say, how do you debug? So if you have any error related to, let's say, account service, so what you can do is that you can log into the history stream, and you can see if account service has any error, or if any request that failed. Over here, not much request, so you don't see much of statistics. I think that's pretty much about the demo. And if you want to look at the code base, I'll quickly just show you. So over here, every service is like an independent application. So it has its own pom.xml. Over here, it is getting generated as the runnable jar, and then it is deployed in a Docker container. So every service is like an independent application, you can say in that layman terminology. So, monitoring, notification, registry, everything. So we don't clump everything together into any war or anything. As you can see, everything is getting generated into its independent jar. These are runnable jars. Okay. So this is the demo I took you through. So this is not my code. This is somebody else's on the Git. These are the references that I would recommend you to go through. I know once the session stops, you would hardly go through anything. Initially, maybe you will be motivated, but after 1 or 2 days, story would be the same. But if you really want to learn microservices and spend some time, understand things, because I think if you face any interview from any good IT company, they will definitely ask you questions on system design, right? Okay, so that's all about the microservices, and thanks for watching the video. If you like my video, please click on the like button and subscribe to this channel. Thank you.